Assalamualaikum and a very good afternoon to the judges. Hi, I'm Nurul Fatihah Nazwa from UiTM Police. Today, I want to present about the desulfurization and optimization of the high sulfur Jambi coal by the ultrasonic assisted process using the peroxyacetic acid, or we call it as a PA treatment. Coal is a dominant fossil energy source that continues to play the important role in the many types of industrial in this world. Direct combustion of the high sulfur coal creates a hydrogen sulfide and sulfur dioxide gas that can make the air pollution by the forming acid rain. This can harm the agricultural goods and destroy the ecological beauty. Sulfur can be found in a pyrite, organic, and sulfate form. Heterocyclic sulfur is the one of the most sulfur that be difficult to be removed from the coal. Heterocyclic sulfur is present in a mercaptan, disulfides, and thiophene. Heterocyclic sulfur is attached to the micromolecular structure of the coal, and this makes the carbon-sulfur bond must be broken to ensure that this sulfur is successfully removed. Still, the removal effect is not significant, even it can destroy the micromolecular structure and properties of the coal. What is peroxyacetic acid, or the PAA? PAA is the mixture of the hydrogen peroxide in the acetic acid. As a mild-oxidizing agent in the coal desulfurization, PAA can produce the hydroxy red cation, the strong electrophile that react with the sulfur atom because they are more nucleophilic than the carbon atom. They are more quickly remove the pyrite, mercaptan, and thiophene with the process of the microwave. But the heterocyclic sulfur, just as the thiophene, remain unchanged due to the structural stability. So that the ultrasonic desulfurization has been chosen in this study as it was better than the ultrasonic treatment alone, because it can improve the hydrophobicity, superficial area, and the chemical absorption of the coal. There are four types of the treatment process, which include the physical, the microbial, physicochemical, and the chemical process. The chemical process is the one of the most effective method for both inorganic and organic sulfur removal from the coal. The investigation have made use of the valuable experimental design approach known as the design expert. It has a many benefits, with one of them is to cut down the cost and the less time needed to complete the lab work. It also can offer the motivating array of the planned alternatives and give the user a chance to pick out the particular aspects. The objective of these applications is to find the relationship between the various factors for the parameter optimization and also provide the statistical framework. The objective for this study is to investigate the impact of the peroxyacetic acid pretreatments on the coal desulfurization using an ultrasonic assisted extraction system. Next, to identify the optimal concentration, temperature, and processing time for the coal desulfurization process using the Central Composite Design CCD-RSM. To characterize the treated coal by using the advanced instrumental analysis as supporting evidence for desulfurization and ultrasonic process compared to the raw coal. The sample is the high sulfur coal that provided from the Jambi province, Indonesia. The coal is crushed and sieved according to the particle size of 212 micrometer and dry in a vacuum oven at 18 Celsius for 24 hours. After that, keep in a screw cap bottle to remove the moisture. Next, we go through the chemical desulfurization using the PAA. 5 grams of the coal sample will be added into the peroxyacetic acid solution. Then it will be undergoing the ultrasonic treatments. And then the residual solution will be washed with the hot distilled water. After that, the solution will be filtered and dry in a vacuum oven at 80 Celsius for 24 hours. Then, the coal waste will be kept in a screw cap bottle for further analysis. Total sulfur in the coal was tested using ASTM 3177. For ASTM 2492 was used to identify the sulfate and pyrite sulfur. For the organic sulfur calculations, minus the sum of the pyrite and sulfate sulfur from the total sulfur. And then, for the percentage organic sulfur removal, was used the equation in this slide. The untreated aqueous solutions was potassium iodide was used as the reference. There were two peaks with 306 nanometers and 354 nanometers. 354 nanometers was broader than the other peaks as the absorbance was directly proportional to the ion concentration and it was chosen to characterize the iodine concentration. Table 1 shows that the characterization of the raw coal, which include the proximate analysis, ultimate analysis, form of sulfur, and the calorific value. For the next one, it's the effect of the PA treatment on the microstructure of the coal. The appearance of the hollow pits at the surface of the treated coal is caused by the disappearance of the pyrite and the dissolutions of the some mineral matter from the surface of the coal. The sulfur content decreased in the treated coal as the sulfur-bearing minerals were completely soluble during the desulfurization. The major content of the carbon was found in the optimum condition, with a greater amount of minerals constituent silica and alumina were carried out. FTIR result shows that the peak and the functional group assigned. The functional group assigned shows that the existence of the hydroxy radical, thiol, the thiopherenes, the sulfoxide, and also the disulfide. 3 variables were selected to study their effect on the percent of the organic sulfur removal from coal, include the molar ratio of the concentrations of the PAA, the temperature and the time, and this will be optimized by using the Central Composite Design CCD under the RSM in a design expert where the 18 experimental runs were proposed. And this slide I also shows that the percent of organic sulfur removal that get from the RSM. This slide shows that the CCD experimental design with the experimental and predict percentage of the organic sulfur removal. 18 runs has been conducted in this study. And this study shows that the concentration ratio of the 70-30 was the highest organic sulfur removal as it get the 43.54% of the organic sulfur removal. The model F value of 2062.37 suggests that is significant. The length of the fit of the F value is 2.30, which is insignificant compared to the poor error. This has determined an 18.91% probability of being caused by the noise. The predicted R-square 0.9959 and adjusted R-square 0.990 correctly predict that the result because the difference between the two is less than 0.2. This figure shows that the normal probability plot of residual, the plot of predict versus the actual. It is demonstrate that the values are still within the acceptable limits. For the next one, shows that the effect of the PA solvent and extraction parameters. For the first one is the effect of the concentration. When the concentration at the ratio of 18:20, the slope of this curve was the lowest as the production quantity of the hydroxy radical was the least. The slope of the curve increased with the concentration increase, shows that the concentration reached the maximum at the ratio of the 70:30, then it decreased after achieving the concentration. The effect of the temperature. The slope of the curve increased firstly with the increase of the temperature and decreased as the temperature was over 30 Celsius. This study shows that the maximum production rate of the hydroxy radical was obtained at 30 Celsius. Tan et al. Studied that the temperature was helpful to the formations of the cavitation bubbles at the beginning, but when the pressure increased inside the cavitation bubble, it enhanced the rupture of the bubble after the temperature is over the 30 Celsius. Effect of the time. The slope of the curve increased first and decreased as the time was over 30 minutes. However, the activity of the oxygen hydroxy radical and the hydrogen peroxides produced by the ultrasonic reaction is increased to the rising of the pulp temperature, which speed up the oxidations of the sulfur surface and cause the sulfur to form the sulfoxide unit in the pulp. The effect of the concentration on the total sulfur removal rate is shown in this figure. With the concentration increasing, the desulfurization rate increased first and then decreased as the concentration was presented at the 70%. The maximum desulfurization was presented at the ratio of the 70:30 for the 30 minutes. According to this figure, when the time passed in the range of the 10 to 30 minutes, the percentage of the organic sulfur removed at the 30 Celsius increased. As the temperature continued to rise from 70 Celsius to 84 Celsius, the percent eliminations of the organic sulfur was observed to decline. So, this finding shows that the increase of the temperature could accelerate the desulfurization reaction, but a low temperature made the desulfurization process work better. Figure E and F show the interaction of processing temperature and concentration with time on the percentage of the organic sulfur removal. According to the data, extend the time from 3 to 37 minutes has no consistent effect on the percentage of the organic removal. The temperature and reaction time are directly proportional to the percentage of the organic sulfur removed as the ANOVA analysis. Peroxyacetic acid was efficient to remove the organic sulfur in the coal, and for the sulfur removal is 43.54%. The optimum that suggested by the CCD-RSM was found at the concentration of the ratio 70:13 at 30 Celsius for 30 minutes for processing time. Further tests need to be conducted using the SPS and also the SRD are required. Thank you.